Welcome viewers, live on Twitch, and hello YouTube. ChatGPT, let's make a course on Go. Let's learn about Go. Okay, ChatGPT, write an outline of a course on Go for beginners. Let's see what it gives us this time. It's thinking. I'll take a drink of water. Here we go. 1. Introduction to Go. A. Overview of the Go programming language. B. Setting up the development environment. C. An introduction to the basic syntax of Go. 2. Variables and data types. A. Declaring and initializing variables. B. Types of data in Go. String, integer, float, boolean, etc. C. Type conversion and type inference. 3. Control structures. A. Conditional statements. If else, switch. Ooh, switch, that's nice. B. Loops, for, while, range. I didn't know there was while loops in Go. C. Breaking and continuing statements. 4. Functions. A. Defining functions in Go. B. Function parameters and return values. C. Anonymous functions and closures. Oh, that's interesting. 5. Arrays and slices. That's interesting that they put functions before arrays and slices. A. Declaring and initializing arrays. B. Manipulating arrays and slices. C. Slices versus arrays. 6. Maps. A. Understanding maps and their usage. B. Creating, reading, updating, and deleting elements in maps. Okay, that's good. C. Map literals and make function. 7. Structs and interfaces. A. Defining and using structs. B. Embedding and anonymous fields. C. Introduction to interfaces and their implementation. 8. Concurrency. Ooh, concurrency is good. A. Go routines and channels. B. Concurrent programming patterns. C. Wait groups and select statements. 9. Error handling. I feel like we could have done error handling earlier. But A. Go's approach to error handling. B. Defining and using custom error types. C. Panic and recover. 10. Final project. Part A. An opportunity for students to apply what they have learned in the course. It's moving kind of slowly, but that's okay. B. A practical project that showcases the concept learned in the course. C. A discussion of project design, implementation, and best practices. 11. Conclusion. A recap of key concepts covered in the course. B. Discussion of next steps for students who want to continue learning Go. C. Final thoughts on the Go programming language and its usage. Okay. So that's the outline of the course, and I plan to ideally work through this entire thing. Let's go back to let's go back to the beginning, and I'm going to ask it to tell me an overview of the Go programming language. Scroll down. Go is an open source, statically typed, compiled programming language developed by Google. It was designed to address issues with large software systems such as slow compile times and difficulty with parallelism and concurrency. Go was released in 2009 and has since become a popular choice for building high-performance, scalable, and concurrent systems. Go is often described as a simple and easy-to-learn language with a minimalist syntax and clear, concise structure. Its standard library provides a rich set of packages for a variety of tasks, such as networking, web development, and data processing. Go is also well suited for systems programming and has become a popular choice for building cloud services, web servers, and networking tools. It's highly concurrent with built-in support for concurrency through Go routines and channels. This allows developers to write parallel and scalable code more easily and with less complexity than in other programming languages. Go is a statically typed language, meaning that the type of a value is known at compile time, as opposed to dynamically typed languages where the type is determined at runtime. This allows for improved performance and ensures that type-related bugs are caught early in the development process. In conclusion, Go is a fast, efficient, and modern programming language that's well suited for building high-performance, concurrent, and scalable systems. Its minimalist syntax, rich standard library, and strong support for concurrency make it an attractive choice for a variety of programming tasks. Thank you, ChatGPT. What do we have next? Setting up the development environment. Instead of relying on ChatGPT for this one, I'm going to use a Replit environment. And you can go to replit.com, sign up, and create a Go Replit, which is an online IDE built around the Go programming language. And it automatically provided me with a hello world function. And let's just run this to prove that it's working. Make run, interesting, /main hello world. And there we go. That's good. Now I'm going to say, introduce the basic syntax of Go. I'm not sure how well this one's going to go, but let's try it. Go's syntax is simple, clean, and easy to read, making it a great choice for new programmers. Here are a few key features of Go's syntax. Variables. Variables in Go are declared using the var keyword, followed by the variable name and its type. For example, var xint declares an integer variable named x. Constants. Constants in Go are declared using the const keyword, followed by the constant name and its value. For example, const y_int equal 10 declares an integer constant named y with a value of 10. Oh, we got some code here. Functions. Functions in Go are declared using the func keyword, followed by the function name, its parameters, and its return value. For example, func add xint y_int int declares a function named add that takes two integer parameters and returns an integer. Don't worry if that went a little over your head, because we're going to come back to it in a later section of this. Control structures. Go has support for standard control structures such as if, else, for, and switch statements. For example, if x greater than 0, braces, fmt.println x is positive, else fmt.println x is not positive. 5. Semicolons. Go uses semicolons to separate statements, but unlike some other languages, they are optional and can be omitted if statements are on separate lines. 6. Importing packages. Go uses the import keyword to import packages, which are collections of code that can be used in your program. For example, import fmt imports the fmt package, which provides input-output functions. Comments. Go supports both single-line comments beginning with // and multi-line comments enclosed in /*/. These are just a few of the basic Go syntax, and there's much more to learn, but this could give you a good starting point and help you get familiar with the syntax and structure of Go code. Well, let's make an example out of this. Let's say write a Go program that declares an integer x, sets its value to 5, and prints its value. Okay, ChatGPT says, here's a simple Go program that declares an integer x, sets its value to 5, and prints its value. Okay, we have package main, import fmt, func main, brace, var x int, x equal 5, fmt.println the value of x is, comma, x. In this program, well, let's just run it first. Copy the code, go to my replit, paste all that code, run. The value of x is 5. Okay, let's go back to the discussion of the program. In this program, the first line specifies that it belongs to the main package, which is the entry point for a Go program. The import statement imports the FMT package, which provides functions for formatted I/O operations, such as printing to the console. I/O means in and out. The main function is the entry point for the program, func main, and it declares an integer variable x using the var keyword, var x int. The value of x is then set to 5 using the assignment operator equals, and finally the value of x is printed to the console using the fmt.println function along with a string to provide context. This is a very simple Go program, but it demonstrates the basic structure and syntax of a Go program and shows how to declare variables, set their values, and print values to the console. Thanks, ChatGPT. That was helpful. Let's see here. Constants, functions. I think we'll get into those things later. Variables and data types. I'm going to say, tell me about declaring and initializing variables. In Go, variables can be declared using the var keyword. We saw that above, but we'll go on about it now, followed by the variable name and its type. For example, var x int. This declares an integer variable named x. By default, Go initializes variables to their 0 value, which is 0 for numbers, false for booleans, and an empty string for strings. We will hear more about booleans and strings later. You can also declare and initialize a variable on one line. Var y int equals 10. In this example, a variable named y of type int is declared and initialized to the value 10. If you're declaring multiple variables of the same type, you can declare them in a single line. Var a, b, c int. In this example, 3 integer values a, b, c are declared in a single line. Go also supports shorthand syntax for declaring and initializing local variables. Instead of using the var keyword, you can use the colon equals operator, which automatically infers the type of the variable based on its initial value. Z colon equals 20. In this example, a local variable z is declared and initialized to 20, and its type is inferred to be int. Note that the shorthand syntax can only be used inside functions and can't be used to declare variables at the package level. Let's look back here to our, here's a function, and we could use that shorthand syntax inside of this function, but we couldn't use it as at the package level out here. That's kind of what it's talking about. In conclusion, variables in Go can be declared using the var keyword and can be initialized either at declaration time or later in the code. Go supports shorthand syntax for declaring and initializing local variables, which can simplify your code and reduce the amount of boilerplate needed. Okay, thanks ChatGPT. What do we have up next? Tell me about the basic types of data in Go: string, integer, float, boolean, etc. Go has several built-in data types that are used to represent different kinds of values. Here are some of the most commonly used basic types in Go. 1. String represents a string of Unicode characters. Strings in Go are immutable, meaning that once a string value is assigned to a variable, it can't be changed. Int and int64 represents signed integers of varying sizes. Int is 32 bits on a 32-bit system and 64 bits on a 64-bit system, while int64 is always 64 bits. Huh, that's interesting. Float32 and float64 represent floating point numbers with varying precision. Float32 is single precision floating point number, while float64 is a double precision floating point number. Bool represents a Boolean value, which can either be true or false. Rune represents a single unipoint code point and is equivalent to int32. Byte represents an 8-bit unsigned integer. Byte is an alias for uint8. Complex 64 and complex 128 represents complex numbers, which consist of a real and imaginary component. Complex 64 has single precision real and imaginary component, while complex 128 has a double precision real and imaginary component. These are the most commonly used basic data types in Go, and there are several others that are used for more specialized purposes. By choosing the appropriate data type for your variable, you can ensure that your program is efficient and has the necessary precision for your use case. Okay, cool. I want to dig into int type. Write a Go program that demonstrates integer overflow of the int type. Okay, here's a Go program that demonstrates integer overflow of the int type. Package main import fmt func main var xint equals 21474837647. Let's just let's read about it. It's getting ahead of me. Huh. Okay. Package main import fmt func main var xint equals 2147 blah 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 fmt.println x comma x x equal x plus 1 fmt.println x comma x. In this program, we declare an int variable x and set its value to 2147, etc., which is the largest value that can be stored in a 32-bit int on most systems. We then add 1 to x, which should result in 2147483648, but instead it overflows and becomes negative, producing the output x is 214, blah, blah, blah. X is negative 214, blah, blah, blah. This demonstrates that when an int variable exceeds its maximum value, it wraps around to the minimum value, producing an overflow. Note that this program demonstrates integer over for a 32-bit int, but the behavior is similar for other integer types. If you need larger range of values, you can use int64 or other larger integer types in Go. However, keep in mind that the larger integer types use more memory and may be slower than smaller integer types. Let's copy this code into Replit and see if we're dealing with a 32-bit system. Oh, that's interesting. It did not fail. It actually went to the correct thing. So this, but if I say int32, then we'll have the desired mistake. Let's try it. Yeah, then when I do int32, it goes from this number 47 to negative that number ending in 48. But if I do int, just plain int, it's like I'm doing int 64, because apparently Replit servers give us a 64-bit system. Yeah, you can see it continues positive. We can also play around with this using uint32. Wait, is that that's gonna be a different behavior? Because that I want uint16, maybe. No, I don't want uint16. That's an overflow. uint32, if I take that times 2, I need to either think or ask ask ChatGPT for help of the uint. Let's try uint16. Okay, I asked it now to write a program that demonstrates integer overflow of the uint16 type. Here's a Go program that demonstrates integer overflow of the uint16 type. Let's copy this code over. Go here. Var x uint16 equals 65,535. We'll run that. And it overflows from 65,535 to 0. That's nice. That's a nice result. So when it's a signed int, it overflows to a negative value, but when it's an unsigned int, it overflows to 0. Okay, let's see what the commentary from ChatGPT tells us. Let's read the program. Let's actually make this larger. Here's a Go program that demonstrates integer overflow of the int type. Interesting, it doesn't specify. Oh, that's because I scrolled down. Of the uint16 type. There we go. Package main import fmt. Package function func main var x uint16 equals 65,535. fmt.println x, x equal x plus 1, fmt.println x, x. In this program, we declare a uint16 variable x and set its value equal to 65,535, which is the largest value that can be stored in a uint16. We then add 1 to x, which should result in 65,536, but instead it overflows and wraps around to 0, producing the output x 65,535, x0. This demonstrates that when a uint16 variable exceeds its maximum type, it wraps around to 0, producing an overflow. Notice that this behavior is similar for other unsigned integer types in Go, including uint32 and uint64 and others. If you need a larger range of values, you can use larger unsigned integer types in Go, but keep in mind that larger integer types use more memory and may be slower than smaller integer types. Neat. Okay, I think we've said enough about excuse me. I think we've said enough about integers. Let's move on to type conversion and type inference. Go has two ways to convert values between different data types, type conversion and type inference. Type conversion is the explicit conversion of a value from one type to another. In Go, type conversion is performed using a typecast, which is written as an expression of the form t paren v, where t is the desired type and v is the value being converted. Here's an example. Package main import fmt func main var I int equals 42, var f float 64 equals float 64 of I, fmt.println f. In this example, we declared an int variable I, set its value to 42. Then we used a typecast to convert I to a float 64 and assign the result to a float 64 variable f. Finally, we print the value of f. Note that type conversion can result in a loss of precision, so it's important to be aware of the limitations of the target type when converting values. Let's copy this code over to Replit and try it out. It prints 42. Now let's flip this. Let's say float 64 equals 42.0 and var f, oops, let's say var f why is it complaining about I declared but not used. Okay, thanks. Let's make this one step bigger. So I switched it around. We're now starting, let's say 42.5, and we're going to see the loss of precision. It gets chopped down to 42. And even if we had 42.999, it's still going to get chopped down to 42. Yeah. But if we had 43.01, then it gets chopped down to 43. Cool. Okay, that was loss of precision. Type inference. Type inference is a feature in Go that automatically determines the type of a value based on its context. In Go, type inference is performed when you assign a variable to a variable without specifying its type, like this. I equals 42, fmt.println I. In this example, we declare a variable I and set its variable to 42, but we don't specify its type. The type of I is inferred from the type of value that's being assigned to it and is automatically set to int. Type inference can make your code more concise and easy to read, but it can also lead to confusion if you're not careful. If you need to specify the type of a value explicitly, it's best to use type conversion. Cool. I want to now dig into the question of whether int is int32 or int64. Write a Go program to check whether the int type is int32 or int64. I'm interested what it's going to do with this. You can check the size of the int type in Go using the onsafe.sizeof function from the onsafe package. Here's a Go program that does this. Import fmt onsafe var I int size : equals onsafe.sizeof I. If size equal 4, print int is int32. If size equal 8, fmt.println int is int64. Else fmt.println int is an unknown size. Well, let's try this code. I'm confused why 4 corresponds to 32 and 8 corresponds to 64, unless these are unless it's bits to bytes. 8 times 4 is 32 and 8 times 8 is 64. Okay, that makes sense. Copy this code and go over to here, run this one, and I think it's going to say int is int64. Yeah, int is int64. We saw that before in an earlier thing. Okay, what else can I dig into about type conversion and type inference? Let's practice with strings and ints. Write a Go program to convert a string to an int type. Is it convert or is it cast? Type 1, type conversion. Yeah, it's convert. A string type to an int type. To convert a string type to an int type in Go, you can use the string convert package's parse int function. Here's a Go program that demonstrates this. This is different than what I was thinking of, but we'll try it this way and then see if I can try it the way that I was initially thinking of. So, package main, import fmt string convert, s:= 42, 42, I love it. I, error equals string convert parse int s1064. This is kind of getting into stuff about functions that we haven't learned yet. If error not equals nil, format.println error, error, return, then format.println I. In this program, we declare a string variable s and set its variable to 42, then use the string convert.parseInt function to convert s to an int64 type. The parseInt function takes 3 arguments: the string to be converted, the base of the number to be represented by the string, and the bit size of the target value. In this case, we use a base of 10 and a bit size of 64 to ensure that the converted integer will fit in an int64 type. The parseInt function returns 2 values, the converted integer and an error value. We can check for an error by checking the value of the ERR variable. If there's an error, we print a message indicating that what the error is and return from the function. If the conversion is successful, we print the converted integer. Copy this code and paste it over here. And let's run this. 42. Now, let's cut out a bunch of this stuff. s:= 42. What if I : equals int 64 of s? And fmt println of I. We'll take away string convert because we didn't use it. What's it going to complain about here? Cannot convert s variable of type string to int64. Okay, so type conversions of this in this way don't actually work, and it's going to complain if I try to build it. .main.go 916 cannot convert s variable type string to type int64. So you really do need to use the string convert.parseInt function. That's a little bit disappointing, but okay. Let's go back and think about this. We did declaring and initializing variables. We did types of data in Go. I'm sure there's more we could say about that, but let's continue on. And type conversions and type inference we did. So now control structures. Conditional statements. Tell me about conditional statements if in Go, specifically if else. I don't want it to try to explain switch statements in this same section of the course, so let's just do if else. In Go, you can use the if statement to control the flow of your program based on conditions. The basic syntax of the if statement is as follows: if condition, code to be executed if the condition is true. The condition in an if statement can be any expression that evaluates to a Boolean value, true or false. This is an interesting statement. It might be worth digging into a little bit more. Hey, we got 2 viewers. Welcome 2 viewers. If the condition is true, the code inside the curly braces, that's here, will be executed. If the condition is false, the code inside the curly braces will be skipped. You can also use the else statement to specify an alternate code block to be executed if the condition in the if statement is false. The basic syntax of the if-else statement is as follows: if condition, code to be executed if condition is true, else, code to be executed if the condition is false. Here is a simple example that demonstrates the use of an if-else statement in Go. Package main, import fmt, func main, x : = 42. Now remember, this is implicit, or this is type inference, and it's going to give x an int type. We say if x greater than 0, fmt.println x is positive, else fmt.println x is not positive. In this example, we declare an int variable x and set its value to 42. Then we use an if-else statement to check whether x is greater than 0. If x is greater than 0, the code inside the first set of curly braces will be executed and the program will print x is positive. If x is not greater than 0, the code will, inside the second set of curly braces, will be executed and the program will print x is not positive. Now this is kind of a boring program because obviously it's always going to do the f is, it's always going to say x is positive. So let's write a Go program that takes user input, parses the input to an integer, and uses an if-else statement. Is if-else statement the right thing? Yeah, statement is the right thing. Statement to print whether x is positive or not. Here's a Go program that takes user input, parses the input into an integer, and uses an if-else statement to print whether x is positive or not. Package main, import fmt string convert, func main, format print, enter a number, var input string, fmt and scanln at input. I'm gonna ask what that and refers to. X error equals string convert.atoi input. If error not equals nil, fmt.println error, comma error return. If x greater than 0, fmt.println x is positive, else fmt.println x is not positive. In this program, we use the fmt.print function to prompt a user for input. Then we use the fmt.scanln function to read the user's input into a string variable input. Next, we use the string convert.atoi function to convert the input string to an int type. The atoi function takes a single argument, the string to be converted, and returns two values, the converted integer and an error value. We check for an error by checking the value of the ARR variable. If there's an error, we print a message indicating what the error is and return from the function. Finally, we use an if-else statement to check whether the x is greater than 0. If x is greater than 0, the code inside the first set of curly braces will be executed and the program will print x is positive. If x is not greater than 0, the code inside the second set of curly braces will be executed and the program will print x is not positive. So let's first just test out this code. Not that I doubt it'll work, but I want to see it in action. Enter a number, 42, x is positive. Run again, minus 95, x is not positive. Enter a number, 0, x is not positive. Okay, it's working. And let's review the code here. Package main, import fmt and string convert. We print format.print, enter a number, var input string, format.scanln at input. Or and input, that's an ampersand. Let's ask ChatGPT what's up with the ampersand. What's up with the ampersand in fmt.scanln ampersand input? The ampersand symbol in the fmt.scanln ampersand input is used to pass the memory address of the input variable to fmt.scanln function. This allows the function to modify the value of the input variable directly rather than just its local copy. So it's the memory address. This is getting deep pretty quickly. In Go, variables are passed by value by default, meaning that when you pass a variable to a function, the function receives a copy of the variable's value, not a reference to the original variable. This can be problematic when you want to modify the value of a variable from within a function. The ampersand operator allows you to pass the memory address of a variable to a function, allowing the function to modify the value of the original variable directly. When you use ampersand before a variable, it returns the memory address of that variable. For example, ampersand input returns the memory address of the input variable. In the case of fmt.scanln ampersand input is passed as the argument to fmt.scanln, which means that the format.scanln function will read the user's input into the input variable rather than a local copy of input. Okay, that's what the ampersand is all about. Thanks, ChatGPT. X comma error equals string convert ATOI of input. What does ATOI stand for? ATOI is equivalent to parse int s10 converted to an int type. String convert.atoi on package.go.dev. Let's just read about this. Func ATOI string int returning int comma error. ATOI is equivalent to parse int s10 converted to type int. Example. Okay, that's a straightforward example. Kind of straightforward example. It's actually kind of convoluted now that I think about it. But anyway, let's take a break for a drink of water and then get back into it. Okay, what was that about? Oops. Okay, I think we've covered if else pretty well. Let's just review if else. Let's review if else statements. In Go, if else statements are used to conditionally execute a block of code based on the value of a Boolean expression. The basic syntax of an if else statement in Go is as follows: if condition, code to be executed if condition is true, else code to be executed if condition is false. In the above syntax, condition is a Boolean expression that is evaluated to determine whether the code inside the first set of curly braces should be executed. If condition is true, the code inside the first set of curly braces will be executed. If condition is false, the code inside the second set of curly braces will be executed. You can use multiple if-else statements to handle multiple conditions. That's an interesting addition. We have if condition 1, else if condition 2, else. In the above syntax, condition and condition 2 are Boolean expressions that are evaluated in the order that they appear. If condition 1 is true, the code inside the first set of curly braces will be executed. If condition 1 is false and condition 2 is true, the code inside the second set of curly braces will be executed. If both condition 1 and condition 2 are false, the code inside the third set of curly braces will be executed. Okay, I think that's enough for that, but I wonder if we need to cover switch statements. I think it's worth covering. Let's go over switch statements. In Go, switch statements provide a way to conditionally execute different blocks of code based on the value of a single expression. The basic syntax of a switch statement in Go is as follows: switch expression brace case value 1, code to be executed if expression is equal to value 1, case value 2, code to be executed if expression is equal to value 2, ... default, code to be executed if expression does not match any of the case values. In the above syntax, expression is evaluated and compared to each of the values in the case statements. If expression matches a case value, the code inside that case block is executed and the switch statement terminates. If expression does not match any of the case values, the code inside the default block is executed. The default block is optional and can be omitted if you do not need to specify a default case. Oh, that's interesting. In Go, switch statements are more flexible than if-else statements and are particularly useful when you need to handle multiple conditions that depend on the value of a single expression. They can also simplify your code by eliminating the need for multiple if-else statements. Let's see, I want to see an example let's just say write an example Go program using a switch statement. Here's an example Go program that uses a switch statement to determine if an input number is positive, negative, okay, or 0. So we do println, or just print, enter a number, format.scanln at input. Remember that at is the memory pointer to input, so we can actually access the original value of input. Switch, case input greater than 0, case input less than 0, default. That's a nice little program. I like it. In the above program, we use the fmt.scanln program to read the input number and store it in the input variable. The switch statement then checks the value of input to determine if it is positive, negative, or 0. Based on the value of input, the appropriate message is printed to the console. Okay, let's take this for a spin. Oops. Take it for a spin here. Run it. Enter a number. We'll enter 32 first. 32 is positive. Enter a number negative 12. Negative 12 is negative. Enter a number 0. 0 is 0. Makes sense. Okay, that's good. So that's our switch statement. Where is my scroll bar? There we go. Come on, scroll. I don't know why I can't scroll right now. There it goes. Loops. Tell me about for loops. Go provides the for loop to repeatedly execute a block of code. The for loop is one of the most versatile loops in Go and can be used in a number of different ways to accomplish different tasks. Here is the basic syntax for a for loop in Go. For, why is it saying CSS? Huh. But anyway, for initialization, condition, post, code to be executed. In the above syntax, initialization is an optional expression that is executed only once before the loop begins. Condition is an expression that is evaluated before each iteration of the loop. If condition is true, the loop continues, and if condition is false, the loop terminates. Post is an optional expression that is executed after each iteration of the loop. Here is an example of a Go program that uses a for loop to print the numbers from 1 to 5. Package main, oh, why is it telling me CSS? That's annoying. Anyway, package main import, here, let's copy this over to this thing so we get better syntax highlighting. Package main, import fmt, func main, for I, colon equals 1. Let's review, this is type inference. It's going to set I to an integer type, and it's going to be equal to 1 at the initialization. Then the condition is I less than or equal to 5. And since 1 is less than or equal to 5, it will be true and the code will execute. Then the post thing is I++, which means that I increases by 1 integer. And it prints I. So we expect this to print the numbers 1, 2, 3, 4, 5. It's a println, so we expect it on new lines. 1, 2, 3, 4, 5. Okay. Going back to ChatGPT. In the above program, the for loop initializes I variable to 1, and then repeatedly increments I and prints its value until I is greater than 5. This results in the following output: 1, 2, 3, 4, 5. Note that the for loop can also be used without any of these components, in which case it behaves like an infinite loop. Oh, that's kind of fun. Don't even need to write for true, you just write for. This type of for loop is often used in conjunction with a break statement to exit the loop early. We'll get to break statements later. I don't know why I'm having such trouble touching the... I'm surprised that it says while loop here. I didn't think that Go had a while loop, but let's Okay, show me a while loop. It's thinking. Maybe it doesn't know about while loops, and that was a spurious. Go provides the for and while loop to repeatedly execute a block of code. The while loop is a type of loop that continues executing until a specified condition is met. Here is the basic syntax for a while loop in Go. Rust. Why is it Rust, CSS, JavaScript? That's so confusing. In the above syntax, condition is an expression that is evaluated before each iteration of the loop. If condition is true, the loop continues, and if condition is false, the loop terminates. Here is an example of the Go program that uses a while loop to print the numbers from 1 to 5. Func main I colon equals 1 for I less than equal to 5, fmt.println I plus plus. Okay, I see what's happening here. It's just in the above program, a while loop initializes the variable I to 1 and then repeatedly increments I and prints its value until I is greater than 5. This results in the following output: 1, 2, 3, 4, 5. Note that the while loop is a more traditional type of loop and is less commonly used in Go than the for loop. However, it can still be useful in certain situations where a loop needs to repeat until a certain condition is met. What I want to point out about this is it's using the for keyword. So it's really just a special case of a for loop, even though they're calling it a while loop, which I guess is a fair thing to call it. Okay, we have for while range. Show me a loop in Go using range. This is interesting because it kind of needs. Well, let's see what it does. This kind of, I feel like, should come after the bit on arrays. Go provides the range keyword to easily iterate over elements of collections such as arrays, slices, and maps. The range keyword allows you to access each element in the collection along with its index. Here's the basic syntax for using range with an array. For index, comma element, colon equals range array. Oh, index, comma element. I was confused about that earlier in another place. In the above syntax, index is the index of the current element in the array, and element is the value of the current element. Here's an example of a Go program that uses range to print the elements of an array. So package main import Go import fmt func main braces array colon equals. Here we have again type inference. And don't worry too much about this syntax, but basically it's telling us we're getting an array with the numbers 1, 2, 3, 4, 5. For index, column element, colon equals range array, brace, format to println, array element and index, %d is %d. Let's try out this code. I'm going to make it a little more interesting because 5, 27, 3, 44, 52. Just because I want to. Array element at index 0 is 5. Array element at index 1 is 27. Array element at index 2 is 3. Array element at index 3 is 44. And array element at index 4 is 52. What I would like to do now, well, let's finish reading that and then I have an idea for a demonstration. And then I also want to talk more about printf and what this %d stuff is about. In the above program, the range keyword is used to iterate over the elements of the array variable. Pardon me. Of the array variable. For each iteration of the loop, the index and the value of the current element are printed to the console. This results in the following output. Okay. Array element index 0 is 1, and down to array element index 4 is 5. Note that if you don't need the index of an element, you can use the underscore character to skip it. Well, I don't think saying skip it is a very helpful, because we're not skipping that iteration, we're skipping the index. Anyway, we can ignore it that way. For underscore comma element colon equals range array code to be executed. This is if you don't want to use the index in that code. Now, the range keyword can also be used with other collection types such as slices and maps, making it a versatile and convenient tool for iteration in Go. Okay, there's a lot to dig into here, so I need to collect my thoughts and decide which to do first. Let's first talk about why you might want to use this underscore. Let's imagine that instead of saying that, let's just say the current element is, and we delete index from here, and let's try to run this. But notice that before we even get to running it, we're just building it. Index declared but not used. Go is enforcing clean code styles on us. So we have to say, hey, Go, we're not actually going to use what comes out of range in the first position, but we have to put it somewhere. So just put it in this underscore and then forget about it. That's what's happening there. And now we can build main and then execute main. The current element is 5, and then 27, and then 3, and then 44, and then 52. Okay. What else is worth touching here? I want to explain %d in tick that. The %d in ff.println array element and index %d is %d%n index element is a format specifier used in Go's FMT package. %d format specifier is used to represent an integer value. In the fmt.printf function, the first argument is a string that defines the format of the output. The format string contains placeholders for the values to be printed, which are specified in the subsequent arguments. Each placeholder is introduced by a % symbol, followed by a character that indicates the type of the value to be printed. In this case, the format string is array element and index %d is %d /n for new line, which specifies that 2 integer values should be printed. The first %d placeholder is for the index of the current array element, and the second %d placeholder is for the value of the current element. Index of the current array element and value of the current element. The values for the placeholders are specified in the remaining arguments to fm.printf function, index, and element. These values are substituted into the format string in place of the corresponding placeholders, resulting in the final output string. The /n character at the end of the format string is a new line character, which is used to print a new line for the output. When we think about language design, we could maybe have said print FLN, but that seems overloaded. I don't know if I'm using overloaded in the quite technically correct sense, but yeah. Okay, what else? So that was range. Let's go back. Breaking and continuing statements. Tell me about breaking and continuing statements. An error occurred. Ooh, regenerate response. Oh no, do I have to think for myself now? I wonder if it's just like my chat got too long.